I am in the exercise book on page 88, and we are still working with slope and graphing linear equations. We're looking at number 11. Which scenario would most likely be represented by a line? How many albums Y you have of each artist X? How many albums Y you download each month X? How much you spent Y throughout the year on music items X? The total cost Y of downloading X number of albums at $2 per album. The total cost Y of buying music X from different websites. Now we can make this incredibly complicated, but I want you to look at these 5 choices and tell me the one that's different. Just when you read it, just on the surface, common sense, which one is different? It's this one. This one gives you a constant rate. It gives you the constant rate. It defines the constant rate of $2, that's dollars, for one album. And because of that constant rate, this is a linear equation. And I'm just going to leave it there. If you have this question on a test, rather than trying to sketch all these graphs and figure out what's going on, look for the one of the 5 choices that is different visually. And that will help you get to that concept of constant rate. That's a slope right there, 2 to 1. Okay, number 12. Consider the following graph. I like to see intercepts on any graph. I may or may not need them. I also like to know that slope is positive on this one. And I haven't even read the question. This is just something I do when I have a graph. This is Harold's graph of the equation y equals negative 2x plus 2. Well, I can already tell you that Harold has a problem because that slope is positive and Harold's slope is negative. So something is wrong with his situation here. Then he moved 2 units down and 1 unit to the left and plotted the point negative 1, 0. So negative 1, 0. Okay, that's this one that we already plotted. What mistake did he make in his steps to graph y equals negative 2x plus 2? He plotted the incorrect y-intercept. He didn't plot the point negative 1, 0. That's just a false statement because it said that he did. Starting at the y-intercept, he then moved 2 units down. That's true. He did that. After moving 2 units down, he moved 1 unit to the left. That's true as well. He started at the origin and moved up 2 to plot the y-intercept. That's a true statement. But they're asking me what mistake he made in doing this. Okay, in Harold's equation, slope, let me do it up here, slope is negative 2, and we could say negative 2 over 1. Let me ask you this. I'm trying to figure out how to explain it. This is saying that you move down 2 units, and you move 1 unit to the left or right? To the right, because that 1 is positive. Look at D. He moved 2 units down. That was good. No problem there. But then he moved 2 units to the left, and that's where he has the problem. He should have gone to the right. Because the 1 in that slope is positive. He should have gone to the right. So D is the mistake that he made. Number 13. Which graph has a negative slope but positive y-intercept? So they're giving us 2 conditions that have to be met here. Okay, this has no slope. Slope is 0. It's not positive and it's not negative. It's horizontal. So that does not have a negative slope. We can eliminate that one. B has a negative slope. So that could be the answer. C has a negative slope. That could be the answer. And rather than keep writing this, I'm just going to copy and paste it. D has a positive slope, so that cannot be the answer we're looking for. And E has no slope. It's 0 because it's horizontal. So it must be B or C. Now the other condition was a positive y-intercept. So this one intersects right there, and this one up here. So let's get the points. This is 0, negative 2, and this is 0, positive 2. That's the one we want. This is a negative 2, that's a positive 2. They want us to give them the positive y-intercept. So I like C for that one. And that was all on that page.